Welcome my dear students. Myself Sir Sunil, your physics teacher. Good morning to all. How are you? I hope you all are fine and you all are enjoying the holidays. Okay, in between you have to study also. And I have already given to you unit first question answers. Okay, don't forget it. Start to complete your copy work. It will be helpful for you when class starts. Your workload will be less. Okay, and from our unit second, physical quantities and measurement, today we are going to discuss an important point, principle of flotation. All of you, please take out your book and watch this video carefully. Okay students, here is our topic, principle of flotation. When a body immersed in a liquid, the following two forces act on it. First one, the weight of the body W acting vertically downwards. Two forces act on the body when it immersed in a liquid. Okay. First one, the weight of the body W acting vertically downwards. This force has a tendency to sink the body. This force, the force which acting vertically downwards, has a tendency to sink the body. And second one, that is buoyant force of the liquid FB acting vertically upwards. Buoyant force of the liquid FB that is acting vertically upwards. One force that acting downwards, that is W. FB, the buoyant force that acting vertically upwards. Okay students, the buoyant force is equal to the weight of the liquid displaced by the immersed part of the body. This force has a tendency to move the body up. The buoyant force has a tendency to move the body up. Okay, first one force W. That force has a tendency to sink the body. Same time, the buoyant force has a tendency to move the body up. You understood now the difference between the force W and FB. W and FB. Okay, understood now? And now there can be the following three possibilities. Keep in your mind the important point W and FB. Okay, by keeping this point in your mind, we can discuss some important cases. The weight of the body W is greater than the buoyant force FB. W greater than FB. Okay, in this case what will happen? W is greater than FB. In this case, what will happen? We are going to discuss. Okay, students. In this case, the resultant force on the body is W minus FB, which acts downwards. W minus FB. The body will sink in the liquid to the bottom under the influence of the resultant force W minus FB. The body will sink. In this case, the body will sink because W is greater than the buoyant force FB. This is shown in the figure 2.7. Just observe it. Okay, this happens when the density of a liquid is greater than the density of the liquid. This happens when the density of the solid, okay, this happens when the density of the solid is greater than the density of the liquid. The body sinks. In this situation, the body sinks. Solid sinks in liquid when the density of the liquid is greater than that of the density of the liquid. Okay, students. Now, second case, the weight of the body W is equal to the buoyant force Fb. The weight of the body W is equal to Fb. In this case, what will happen? Okay, the resultant force on the body is 0. In this case, when W is equal to Fb, the resultant force on the body is 0. That is, the apparent weight of the body is 0. The body will float just inside the surface of the liquid. In this case, the body will float just inside the surface of the liquid. This is shown in the figure 2.8. The body that will float. This happens when the density of the solid is equal to the density of the liquid. The flotation, the body will float when the density of solid is equal to the density of the liquid. Okay, students. Now, next point, case 3, the weight of the body W less than that of the buoyant force, means W less than Fb. Here Fb is greater than W. Okay. In this case, the resultant force acts on a body upwards. The body will float partially above the surface of the liquid. Only that much portion of the body will immerse inside the body, by which the weight of the liquid displaced Fb, buoyant force, balances the total weight of the body. This shown in the figure 2.9. Half of the body is immersed. Half of the body that is immersed. Half of the body is immersed in the liquid, and half of the body upside the surface of the liquid. Okay, students. This happens when the density of the solid is less than the density of the liquid. Now, while floating, the condition is Fb should be equal to W. So, apparent weight is 0, the second case. Okay, students. Now, thus a body of density greater than the density of liquid sinks inside the liquid, while a body of density equal or less than the density of liquid floats on the liquid. The dependence of a solid, a liquid, on its density to float or sink in a liquid can be understood by the following activity. Here is activity 6 we are going to observe. Okay. Take a cork and a piece of wood, an ice cube, an iron nail, a small brass coin as solids. Take water, turpentine and glycerin. Okay. Take 3 liquids, water, turpentine and glycerin in different beakers as liquids. Label the beakers as A, B and C. Okay, 3 liquids we have taken: turpentine, glycerin and water, and also the solid pieces: cork, piece of wood, an ice cube, an iron nail, a small brass coin we have taken. Okay. Place each solid one by one on the surface of liquid contained in beaker A. Note whether the solid sinks or floats. What we have to observe? Whether the body or the solid sinks or floats. Record your observations. Okay. Repeat step 2 with the liquid of beaker B and C respectively. This activity you can do at home. Observations you can write here itself. Okay. It's a homework for you. Okay. If you have any doubts, we can discuss in the class directly. Okay. From the table of density of some substances, record the density of solids and liquids used above. Here also you can write density of liquid and density of solid. Relate your observations of sinking or floating of a solid in a liquid with the densities. What do you conclude? Okay. This is your project. Okay. In holiday you can do. Okay. And also we will do this activity directly in the class. Okay. It's a video class. It's not possible to do now. You know very well. Okay. So now we are going to discuss about the law of flotation. Law of flotation. When a body floats in a liquid, the conditions we have discussed. Okay, about the W and FB, the conditions we have discussed now, just now itself. Okay, when a body floats in a liquid, the weight of the body displaced by its immersed part is equal to the total weight of the body. This is the law of flotation. While floating, weight of the floating body, okay, the weight of the floating body is equal to the weight of the displaced liquid by its immersed part. Okay, weight of the floating body is equal to weight of the liquid displaced by its immersed part. That is the law of flotation. In other words, according to the law of flotation, the apparent weight of the floating body is 0. A body floats with its major portion outside the surface of the liquid of higher density than that of a liquid of low density. A body floats when? A body floats with its major portion outside the surface of the liquid of higher density than that of the liquid of low density. This can be demonstrated by the following activity. Okay, students. Now, activity 7. Take two identical small blocks of wood. Label them as A and B. Take two identical small blocks of wood. Label them as A and B. Take water in a beaker labeled as P and glycerin in another beaker labeled as Q. Okay, here is the diagram. Okay, A and B, the body A and B. Okay, in this beaker there is water, second beaker there is glycerin. Okay, in beaker P there is water, in beaker Q there is glycerin. Okay, students. Then place the wooden block A on the surface of water in beaker P and the wooden block B on the surface of glycerin in beaker. You will notice that both the blocks A and B float. Why? The block A floats in water with its less portion outside the water surface than the block B, which has its major portion outside glycerin surface. You can see in the diagram. Okay, both position in water, the major position immersed in the water, but in glycerin the major portion of the body upside the surface. Okay, why? What is the conclusion? The density of wood is less than the density of water as well as the density of glycerin. the density of wood is less than the density of water as well as the density of glycerin. Second point, the density of glycerin is more than the density of water. These are the two conclusions we can see in this activity. First one, the density of wood is less than the density of water as well as the density of glycerin. Second one, the density of glycerin is more than the density of water. Okay, please underline and keep. Okay, now we are going to discuss about some application of flotation. Okay students, it's a time to wind up the class. If you have any doubt in today's portion, okay, you can ask me directly when class starts. Okay, we'll explain it once again if you have doubts. Okay, so today I am going to wind up this session. Thank you and have a nice day.